Hello friends, welcome to your own channel on data science, machine learning and artificial intelligence. We are learning Apache Airflow. We are learning to build data pipelines using Apache Airflow. In this part of the video, we are going to understand the concept of connections and hooks. I'll directly take you to the Apache Airflow website where the concepts are explained. This is where the link is, URL you can see. And here we are in the concept section, learning connections and hooks. As part of any data engineering project, ETL data flow pipelines, we will be connecting to external systems, pull data from external system, process that data and push it in data mart, data warehouse, data lake, which means we require our code to connect with the right set of credentials to the external system. We need to open a connection. A connection is essentially you knowing the server IP, the host name, the port on which the server is listening, user password in case we are connecting to database, the database name, the schema name, and this connection which we open, we will give it a unique name called connection, some unique name we will give. So basically Airflow gives you multiple ways by which you can open a connection. You can use command line interface, you can use graphical user interface. We will see how to go about creating a connection in Airflow using the UI. And hooks, what is hooks? To be able to make the connection, the Airflow gives you packages and APIs by which you can connect to various source systems. You can connect to a Postgres database, you can connect to a MySQL database, you can connect to Oracle database, or you can connect to Amazon cloud, you can connect to Azure cloud. For all of these different sources, Airflow gives you a high level interface, a package through which you can easily connect to these source system, and they have been termed, it has been termed as hook. We will see in today's example, we will see how to go about creating a Postgres hook. Now to be able to create a Postgres hook, you will require a package to be installed. So this is the installer which you will have to install on your machine. And now let me demonstrate how you go about creating a connection. I have already installed this package on my machine. On your Airflow graphical user interface, you will see this admin section. In admin section, you will have connections. Click on connections. Here you see there are many options. You can click here on plus to add a new record. Connection ID, you need to give a unique name to the connection that you're opening. Connection type, what kind of source system you are trying to connect. In this case, we will try to connect to Postgres. You can give a definition, description of the connection, host, the IP address where you are going to connect, schema, the name of the database, login, the user ID, password, whatever is the password, port, the port on which the server is listening, extras. For example, you are connecting to a particular database, and in that database you have a schema. In some database, the schema itself is the name of the database. For example, in MySQL, the database name and the schema name is same. Whereas in Postgre, you have a different name for a database, and within a database you have schema. So in extra, you can provide the schema details, and the schema here would be actually the database name. This is how you go about creating the connection. So let me go back. I'll show a connection and how we use the schema. So Postgre default PG ETL. This is a connection which I have opened, created for demo purpose. So I gave a name PG ETL demo, connection type Postgre, database name, some server IP. The database name comes here, login will come here, the password has to be supplied here, the IP address, and the schema. Within the database, you may have multiple schema. I want this connection to by default search in the schema ETL demo schema. Note, this has to be given as a JSON. Also, you should ensure that there are not unwanted spaces. This has to be given in double quote, and the value also has to be supplied in double quote. Extra spaces should not be there in between. Okay, great. So this is how we can open a connection. How do we use it? Let me now go to Visual Studio Code to explain how can we use it. Now, there are multiple ways through which you can open a connection. Here I have created a database connection file. If I have to use the connection which we created using the user interface, using this interface, the connection which I have to use, which is PG ETL demo, my code of opening the connection when I use it would be as simple as I need to import this package PostgresHook, and this I've just created a function. I did not write it, so my code can be a 2-line code to open the connection. This is the PostgresHook package to be imported, and in that PostgresHook module, the function, I will have to specify the connection ID, and this will open the connection for me. Let me undo the code. I'll keep it as a function, so I can call this function anytime in my code and create the connection to the Postgre database. You can use your traditional approach of opening connection in your ETL codes using SQL Alchemy package. So here is this code, SQL Alchemy create engine function, and then in the create engine we pass the user ID, password, IP, server IP, the port number, the database name, and by default I want it to connect to a given schema, so I can pass those additional parameter. This, you note, is a JSON, and this JSON, the additional parameters, is exactly what we pass here in extras. So basically, as the documentation mentioned, it is a high-level interface to an external platform that lets you quickly and easily talk to them without having to write the low-level code that hits the API. So it gave me an interface to create the connection. It gave me an interface to create the connection, and then I can easily use this connection by one line of code. We can do the opening of connection using this approach also. However, the challenge with this approach is all the username, password, IP, and other details, as more specifically the user ID and the password, gets displayed. And the benefit of using the user interface is once you have typed in the login and password, it is secured. Here, when someone opens the code, can easily see the user and password. That's the main benefit. Moreover, it is more user friendly with a user interface. You can easily plug in, test the connection. Now, how do we go about writing a ETL code where we have to fetch data from a Postgres database and then make some insert update in the Postgres database? So here is the DAG. Standard set of packages which we have been using so far has been imported. The standard set of packages. The same code which we have been using so far. I am making modification to the same code. Only thing is, in the previous code, we were not connecting to any external source. In this, I am demonstrating how to connect to an external source. So the change that will happen is, in this Python callable ETL function, this ETL function we have written in this Python file. As I mentioned, we should make our code modular. The DAG code file should be just to structure the data flow. So here you can see I'm showing a small data flow. Start using a dummy operator, ETL, where we are calling a Python callable ETL function where the business logic is written, and a dummy operator just to say, okay, my code is completed. The business logic and technicalities of connecting to database has been moved out in a dbcon.py file here, as you can see. And the ETL part of the code, extracting, transforming, loading, has been moved to a ETL db data.py. In this ETL db data.py, the Python callable ETL function is written. So here the ETL code is written. Now here I have demonstrated the approach of writing the code with the PostgresHook. So here in the ETL, the first line is con object get pghook con. This pghook con function has been defined in our dbcon. So from here, it will return back a connection object. Then I pass this connection object to the extract function. Here is the extract function. In the extract function, I've written a simple query, select star from a table, some table I have mentioned. This is a query. So using the con object, using a get pandas data frame function, we will extract the data. The data frame object is returned back. So the returned object is now captured as e underscore data frame. The commented part of the code, if you don't open a PostgresHook connection using the user interface, if you write the code using SQL Alchemy, in that case you will have to comment this and uncomment this. That's a small change you will have to do. Similarly, you have to uncomment this and comment this. But I'm going to demonstrate this entirely with the PostgresHook. But you can change your code. I have given the SQL alchemy code in the comment section. After extract, this extract object, we are going to pass it to transform. Here, if you want to do any transformation, you can go ahead and do the transformation. The data frame which we get has one column called date updated. I'm making a very small change. I'm changing the date updated value of that data frame column to the current date time now and returning back the object. This is the transform data frame object, which I will then pass it to the load function. To the load function, I'm passing the transform data frame and the con object, which we got using the PG hook. And in load, to insert the data using the connection object, you will have to get the column names. You will have to get the data as rows, iterable tuples captured as col and rows. This is the syntax. And then using the con object called insert row function, give the destination table, rows equal to rows which we got here, and target fields is equal to call the column names that we got here. This is slightly complicated, which I don't appreciate that one should have been doing 3 steps to insert the data. If you see the SQL alchemy approach, which is very neat and clean, if you have to insert the data frame and write to a table, you simply say dataframe.toSQL, give the destination table name and the connection object. If exist, append. If the table already exists, in that case, the content of the data frame will get inserted as in append mode. And index equal to false, we don't want index of the data frame to be written. So this is a much more neater and cleaner approach is what I feel. Anyways, with the PG hook, this is a 3-step. You need to get the column names, the rows, and then you have to call insert rows. Secondly, if you have to call a stored procedure, you will have to get the cursor object from the con. You have to get the cursor object, and then you will have to call the statement execute, call the stored procedure name. With SQL alchemy, this is again a slightly simple step. You directly take the connection object and call the execute function. Anyways, irrespective of simplicity of the style of writing the code, the point is using the hook, Postgres hook, which we have used, which we have created, you can do all the data manipulation activities which otherwise you could have done using a SQL alchemy. And here I have demonstrated in the code how to select data and how to insert data and how to call a stored procedure. This is the code. Let me go ahead and now execute the DAG. The DAG name is example database connection. How do I know that the DAG name is example database connection? Here in the file with DAG, you have to give a name. I have given the name example database connection. Let me just execute this code. You can see there are so many errors while writing the code. To get the right syntax to execute the stored procedure, I had to do some hit and trial. I'll call this DAG, trigger it. Okay, we seems to have some error, and the error is because of some duplicate key error. So let me just show you the log. The log is not opening up. Yeah. So it seems there is some duplicate key error, primary key constraint error, duplicate key value. Okay, I'll truncate that and then rerun the code. In the meantime, let me see. Extraction part of the code executed. There is some data which was there in the table. This was one line data only, which has ID, source, date start, date, and date updated. 5 columns are there, and the values of those 5 columns are these are the values. So the extraction part of the code happened successfully. Transformation happened only when inserting back the data by changing the update date updated. It gave a primary key constraint error. I have truncated the table, made the necessary changes. Okay, I'll now rerun the DAG this time. So graph, and let's rerun the code once again. Because I have made the necessary change, the primary key constraint violation will not happen, and this time around the code has executed successfully. Logs, you can see there was one record which is extracted, and then this record, the date updated, is what we just simply modified just to demonstrate that we can do some transformation, and the transformed data was again reinserted back. Okay, with this you can see how we can easily open a connection. This is the code part, and this is the setting part. In admin, the connections, we can open the connections using, where is that, this one. By giving the appropriate parameters, we can open the connection. This was a quick short demo on connections and hooks in Airflow. We'll keep building upon this to make a full-fledged ETL. I'm explaining the concepts in parts, but then we'll bring all of these concepts together to make a full-fledged ETL. Till then, keep watching. Thanks, and kindly subscribe to our channel and let others know about the good work. If you like the content, then please share with your friends and colleagues. Thank you. Bye bye.